Continuing with our discussion, concavity and points of inflection. This is the next item in our um, guidelines for sketching a graph of any function. Find the second derivative, which we did. All right. I hope we did it correctly. Correct. So now you factor out 6 something. Let's see, 6 comes out, x squared comes out, you factor it, right? Now set it equal to 0. Why? You want to find the cut points all the time. So you are setting it equal to 0. 6x squared is common, which gives me x equals 0. The other factor is 10x minus 14, which gives me x equals 14 over 10 or 1.4. So I get 0 and 1.4 as cut points for my number line, which gives me 3 intervals: negative infinity to 0, 0 to 1.4, and 1.4 to infinity. Okay. Now, choose a test point from each of these intervals. To the left of 0, I have chosen -1. Between 0 and 1.4, I have chosen 1. After 1.4, I have chosen 2. Use these test points in the second derivative. It helps to have the factored version because all we care about is this sign. Plug in -1, -1. What do I get? Square makes it positive, but all of this is negative. See, -1 times 10 is -10. Minus 14. Do I care about the value? No. I care about the sign. It's a negative. That tells me my f is concave down on this interval. Concave down on this interval. The next interval, I'll choose test point 1. Plug it in. 1 squared. Plug it in. 10 times 1 minus 14. Well, this is positive. This is 10 minus 14. Aha, it's a negative. Ah, so it continues to be concave down. On this interval, it is concave down. Now, the last interval, 1.4 to infinity. What is my test point? I've chosen 2. Plug it in. Plug it in. This part is positive. This is 20 minus 14. That's a positive, concave up. So notice one thing, 0, the concavity to the left is concave down, to the right is concave down. There is no change in concavity. Whereas 1.4, to the left is concave down, to the right is concave up. So there is a change of concavity. So 1.4 gives me an inflection point. Whoops, why did I say 0.9? It should be 1.4. Okay, I get inflection point. So what is inflection point? The point where concavity changes. Okay, so I plug 1.4 in my f, original function f, to find the y coordinate. So you have only one inflection point, 1.4, comma. After you plug in, whatever you get, notice these are approximate values I have put in. Okay, this is an inflection point. You got to remember it. Now, finally, we are here to sketch the graph. First, get back to all the important points above and get all the important points we had. Y-intercept, x-intercepts, local maximum value, local minimum value. This is using a fraction, this is using mixed number, and the inflection point. For your benefit, I have already plotted these points here. Okay, now we are ready to graph. Okay, what is the issue? Well, if you remember, going back, you are increasing here, increasing all the way to 0, decreasing from here to here, and increasing again. Moreover, concavity changes here. Before 1.4, you were concave down. After 1.4, you are concave up. So, concave down before, increasing here, decreasing until here, then increasing. All right. I think we are ready to graph. Okay. Increasing before 0. I don't know where I start from. I start from below. And 0 was a local max. I am concave down, if you notice. And here I start becoming concave up. This was a local minimum, if you remember. Oops, my drawing is a bit off, guys. Okay, good. And we keep increasing. Uh-oh, okay. All right. So, concave down, then concave up throughout. Okay. This drawing, I hope you can do better than I can do with my editor here. All right. So let's compare this with a computer generated. Oi, I haven't finished it, have I? This goes to infinity, if you remember the limits. Okay. Okay. So let's try and get a computer generated graph. Okay. So what was my function? 3x to the power 5 minus 7x to the power 4. Aha, looks very similar, doesn't it? There you go. Okay, but I think we can do a bit better by way of zooming, etc. So let me go down, zoom, 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 zoom some more. All right, so it's looking better. Ah, now I lost. Okay, so I would have liked to know see the points better here, but anyhow, this is the best I can do. So I'll put that here, compare this with our graph. You see? So we did okay. What I'm going to do is I'll print this entire page and I will add it to our Dropbox, to our Blackboard folder. And then the next video will be about filling in the blanks here. Until then, bye.